In this video, we want to learn how to calculate the materials that is needed to render this external wall with this given dimension. So look at the information given. Thickness of rendering is 12 mm, mix ratio is 1:4, pitch angle of the roof is 35 degrees, density of cement is 1440 kg per meter cube. That of sand is this. So if you want to get this calculation done to calculate the material that will be needed to render this place, this is what you need to do. First of all, you need to get the total area of this place, deduct this opening. Now, how do you get this area? Now, we know that the pitch angle is 35 degrees, so we need to get the area of this place, area of this other place, because this area of this other place, this rectangular shape, is known by the length by the breadth, and we need to know the area of this place. So how do you calculate that area? Let's have something like this. Let's have something in this form. Let's have something like this. So have it like this. Let's find this place. Let's call it S. From here to here will be half of this place. So half of this 3.5 is 1.75. The pitch angle is 35 degrees. So for us to get S, we need to use SOHCAHTOA. So S will become tan 35 degrees equals to, the opposite is X over the adjacent is 1.75. So our S becomes tan 35 times 1.75. Our S now is equals to 1.23 meter. So we have known the height of our height X. So having known that, for us to get that area, for us to get this area with the knowledge of S, it's not easy. So what we need to do is this: have area of a right angle triangle. Area becomes half base times what? Height, which is equals to half the base. The base is 1.75. The height is the value of S, which is 1.23. So when you multiply out this, we are having 1.08 meter square. So because we have to look for the area here and this area here, I have to multiply what we have by 2. So we multiply this by 2. So this will eventually give us 2.16 meter square. So I've gotten that area. Then let's look for the area of the opening too. The opening is equals to that of the window. The size of the window is 1.2 by 0.9, which is equals to 1.08 meter square. So I've known the area of the opening. Then the area of this shape, the entire rectangle, becomes area of a rectangle is length times breadth, which is equals to, the length is, let's take here 3.5 by 3.1. So if you do that, we have 10.85 meter square. So for us to get the total effective area becomes the area of triangle, area of rectangle 10.85 plus area of rectangle, which is 2.16, minus area of opening, which is that of the window, which is 1.08. This will eventually give us 11.88 meter square. So having known this area, the next is to calculate the volume of material. So the volume of mortar becomes this 11.88 multiplied by the thickness of mortar, which is 12 mm, which is 0.012. So if you have done this, this is given us 0.143 meter cube. This becomes the volume of mortar, but this is wet volume. So let's have the dry volume of it. The dry volume is higher than wet volume by 33%. Let's say dry volume of mortar becomes, we are increasing this by 33%, which is 1.33 multiplied by 0.143. So this will eventually give us what? 0.19 meter cube. So with this, we can as well calculate for the cement and sand. So this is the ratio. This one is for cement, this is for sand. So for cement, the total ratio becomes what? 5. So for cement, we have 1 over what? 5. This is for cement multiplied by the volume, which is 1.9. So the volume of cement in this mix is 0.038 meter cube. So weight of cement becomes 0.038 multiplied by the density of cement, 1440 kilogram per meter cube. So the weight of cement becomes this. $54.72 kilogram. So for us to get bags of cement, the bags needed, bags of cement becomes 54.72 over what? 50 kg over 50. This will now give us